In this video, we're going to talk about a few different ways that angles get specified. Now, in math, we always want to talk about the angle in standard position, so the vector in standard position. So if we put a vector on here in the second quadrant, we want to measure the angle always from the x-axis. So this is our 0-degree line. We've learned that in trig. And we would measure our angle from the x-axis. So we could say that maybe this is 125 degrees. It could also be measured from the x-axis in a negative direction. That's okay, as long as it's measured from the x-axis. Now when we use, so let's, like for example on this one, if we did 360 minus 125, we would get that this angle could also be minus 235 degrees. Either of those is acceptable. Both of those angles are measuring the angle from the standard position. And we know that this is an important concept in math because if I want to write my vector in component form, my vector in component form can be written as the magnitude of the vector times the cosine of the angle, and the magnitude of the vector times the sine of the angle. I can just multiply whatever this vector v magnitude is by the cosine and the sine to get my component form, but only if the angle is in the standard position from the 0-degree line. Now, there are two other ways that are very common to identify vectors, and they have more to do with navigation. Now, I want to point out on this diagram here, if we had vector v and it was at an angle of 125 degrees and I had an xy coordinate, this does not mean that this vector is in a north, south, east, west situation. This might be a hill. This might be the center of an atom and something is pulling it in a direction. It has nothing to do with north, south, east, west. This might be up and this might be horizontal. And those don't have to do with north, south, east, west. This might be above the ground and this might be along the ground. So you have to be careful. When a problem doesn't specify north, south, east, west, you can't use it. So for those of you in physics, don't revert back to north, south, east, west unless that's the context of the problem. Now, there are two different ways to give angles in navigation. The most standard way, the way that pilots use, is called the bearing. We talked about the bearing very briefly at the beginning of our trig unit, but a bearing is the angle measured from north in the clockwise direction. Okay, so if I was to be looking at a vector, and let's say a plane was flying due east. So a bearing has to do with north, south, east, west. So if I had a vector that is flying due east, and let's just give it a 100 miles per hour east. From a bearing standpoint, the angle is measured from the north. And so in terms of navigation, a pilot would say, I'm heading 100 miles per hour at a bearing of 90 degrees. Okay, ships use bearings as well. That is not standard notation for our angle. In our math notation, standard position means that this is the 0-degree line. So 100 miles per hour at a bearing of 90 degrees is the same as 100 miles per hour at 0 degrees in standard position. So you have to be very careful that you know what angle system you're in, because if you want to fly east, you need to make sure that you're all talking about the same thing if you were talking to like an air traffic controller or something like that. So bearing is from north. So let's do one more on a bearing so you can see. If we were to talk about, let's say that we're going to go in this direction here. And from a standard position, our angle is equal to 130 degrees, standard angle. So what is the bearing of that angle? Well, if we're talking about north, south, east, west, because of course that's the only time we would be talking about bearings, we go from the north, we go around clockwise, and we get to there, right? So our bearing is going to be 360 minus this little bit, right? And so what is that little bit? Well, we know this angle in here is 130 minus 90 degrees. So that's a 40-degree angle in there, because this is our 90 degree, of course. And so our bearing is going to be 40 degrees short of going all the way around the 320. And so our bearing on this direction vector is going to be 360 degrees minus the 40. So the bearing would be 320 degrees. So the bearing angle of 320 degrees is the same as the standard position of 130 degrees. Notice that the bearing and the standard position, they're going in opposite directions. The bearing starts at north and goes clockwise. Standard position starts at the x-axis, right? So standard position, this would be the x-axis, and it goes counterclockwise. Now there's one other way that we measure direction that's a common way. And this last way is in navigation again. And this is the common language for navigation. So if I set up a north, south, east, west grid again, and sometimes you'll hear something that says maybe traveled 30 degrees north of west. 30 degrees north of west. So what I like to think of is change this word to off of. Instead of north of west, it's north off of west, because that gives you where you're starting. So I'm going to go to the west line. So here's my west direction, and I'm going to go 30 degrees north off of west. So here's my west, and I'm going to go 30 degrees to the north off of that. And so this angle would be 30, and my direction would be that way. So that angle there is 30 degrees north of west. What is that in standard position? So in standard position, that's going to be 180 minus the 30 degrees. So we're at 150 degrees in standard position. What is the bearing? The bearing of that angle is this way. So I'm going to go 180, 270, and then 30 more. So that's a 300-degree bearing. Okay, so let's try one more like that, and then we'll go back one other piece of this north, south, east, west. So if we said 20 degrees east of south, so that means off of the south line. So I go down to the south line, and I'm going to go 20 degrees to the east off of that south line. So that would be this direction, 20 degrees east off of the south line. What is that in standard position? Well, I could go negative in standard position. So in standard position, that would be negative 70 degrees. Or I could go this way in standard position, and that would be 290 degrees. Those are both legitimate in standard position. In the bearing, we have to start at the north in the bearing, and so in the bearing we're going to go 90 plus 70, right? Because 90 gets us to here. That's 90 degrees in our bearing. And then 70 more down to here. So we would be 90 plus 70, is 160. Or you could think about it as going halfway to south and subtracting, and you still get 160-degree bearing. These angles, these three angles are all the same, but the one that you want to use in our component formula is the standard position. That's the only one you can use to calculate the components of your vector quickly. Now, one last thing about these north, south, east, west. Sometimes you see something like southwest. Now, what southwest means, and many of you who have hiked or been outdoors a lot know this, but southwest means you're going to split halfway. So this is halfway between south and west. So here's my south and here's my west. And so halfway, there's southwest. Okay, so this is our southwest direction. It divides that quadrant in half. Now, what about south-southwest? So if I put on south-southwest, that takes my southwest vector and it splits the difference between the south. So here's my south and here's my southwest. And so there's 45 degrees in here, right? Because these are both 45 degrees for just a plain southwest, gives me the 45 in there. But if I do south-southwest, I split this 45 in half. So I go south of the southwest. So that means that this angle here is 22.5 degrees, right? And this angle here is 22.5. So this would be south-southwest. Now, how could we get that in standard position? Well, we know that this is going to be 270. Let me see if I take this green, right? To go here in standard position, that would be just short of what we would call 270 degrees, right, in standard position. So in standard position, south-southwest would be 270 degrees minus 22.5 degrees. And when you do that, sorry, just want to make sure I give you the right number on the video, is 247.5 degrees. That's the positive. If we wanted to do standard position, right, now this is east, but if we're talking about standard position, we call that 0. We could also go in the negative. So we could go negative 90 and then keep going 22.5. And so this one, same standard position from the 0, would be negative 90 and then another 22.5. And so we get negative 112.5 degrees. These both are the same. And that's the different ways to talk about angles. And what we want to remember is that anytime you want to use this formula, your angle must be in standard position, measured from the 0-degree line is the x-axis, and positive is counterclockwise, and negative is clockwise. We learned this in our basic trig information back in chapter 4. And now, as we're in vectors, if we want to use this formula to calculate the components of our vectors, it makes calculating the components very quick, but that angle must be in standard position.